Hi guys, it's Mrs. Opal
Annika,
and we are here to talk about how many samples, Annika?
one sample.
A one sample z-test for what, Annika? What letter?
P.
There you go, sweetheart. All right, so we're going to start reading. Today, or yesterday, what we did. Are you leaving?
Yeah.
Bye, sweetie. Okay. All right. So what we did yesterday with this one sample z-test for P is we learned just the state part. There are 4 parts to it. Today we're going to add on the plan part. Okay. So without any hesitation, let's get going. The American Automobile Association commissioned a study by researchers at the University of North Carolina on sources of distraction for drivers. The study tracked 70 drivers aged 18 to 80 for a week. Miniature cameras were placed in the driver's car with their knowledge, and their driving behavior was randomly viewed for a week. The 3 hours of each tape were discarded in hope that the drivers would act more naturally later in the week. The researchers considered a wide range of activities to be distracting, such as leaning over to reach for something, fiddling with radio controls, attending to babies, talking to passengers, texting while driving, talking while driving, applying makeup, and opening and reading their mail. The study found that 21 of the subjects used cell phones while their vehicles were moving. Is there significant evidence that fewer than half of all drivers use a cell phone while their vehicles are moving? Okay, so what we need to do is we need to start with the state, what we learned yesterday, the 3 things, the P, the true proportion, the null hypothesis, and then the alternative hypothesis. Sometimes people struggle with, well, how do I know what that true proportion is? Again, remember, you just always go to the question that will usually give you some sort of indication. So what are we looking for? We're looking for the true proportion of what? Of drivers who use their cell phone while their vehicles are moving. So that is our parameter. Now what we need, and again, I want to just give you a friendly reminder, you guys are going to need to pause throughout this because I am going much faster than I normally would during a classroom, okay? Okay, with that being said, let's move on to the null hypothesis. That's your HO. That's going to be a P equals to, and then your H is always going to be a P is greater than, less than, or not equal to. Now, typically we start with the null hypothesis. That's your claim or some kind of assumed truth. But if you go through and you read through that, it doesn't tell us what that is. So when it doesn't tell us what that is, we learned yesterday that you want to go where it talks about what are we looking for then, because that's your alternative hypothesis. So what we're looking for is we're looking for if we have evidence that fewer than half use their cell phone while moving. So that's our HA, that P is less than 0.5. Well, if we know our HA, then we know what our HO, our null hypothesis, has to be as well, because they have to match. Our null has to be P is equal to 0.5. And so I have that right here. Again, some questions are always like, how do I know it's less than? I discussed that yesterday. You want to be looking for words. So in this case, it says fewer. If it says greater, then it would be greater than. And if it doesn't have those words, it's a not equal to, okay? Not equal to. Okay, the next part is the plan. And the plan is important because what we're going to be doing after the plan is the do part. And that's where we're actually going to be using a measurement tool. We're going to be finding a z-score and a p-value. And in order to use that tool, we need to meet some conditions. I talk about it similar when I'm in class. I'll talk about when I was your guys' age, I'd want to go to a rated R movie down at the Man Plymouth Theater, okay? If I wanted to see a rated R movie, they had someone standing outside the movie, or when you bought your tickets and you had to show your ID. That was a condition to see the movie. We have 3 conditions to go ahead and do the do step tomorrow. We have to meet those 3 conditions in order to do that. Okay, so the first condition, and we'll write this down in a second, is the random condition. The next one is the independent condition, and the last one is the normal condition. So I have that all right here. You're gonna, again, like I say, you're gonna want to pause throughout, so do it as you need to. I have random. Random can be a random sample or some sort of random process in the problem, okay? Independent, that's where you're going to take 10 times n. This n is your sample size, which has to be less than capital N. That's your population size. It's not always stated in the problem. For example, if I was sampling 20 squirrels, that's my sample. I don't know the population of all squirrels. I don't know how many squirrels there are. So I would say all squirrels as the population size. That would be my capital N. Then the normal condition, okay? The normal condition is our N, our sample size, times our P, which we know up here from our null hypothesis. That has to be greater than or equal to 10, as well as N times 1 minus B has to be greater than or equal to 10. So let's get going. We need to see up here, is there a random process or a random sample in here? And it says that their behavior was randomly viewed for a week. So what we do is we say random viewing stated in the problem. I always just put stated because it's stated there in the problem. Okay, the next one is the independent. So I take 10, forgive me, 10 times my sample size. So I have to go back up and I say, well, what's my sample size? Is it 21 or is it 70? Now, 21 is not the sample size. That's the part of the total drivers that were tracked, okay? So since we're tracked, so 70 is less than. Well, do we know how many drivers there are out there? No, so we would say all drivers. And then we would do the normal condition. That's the N times P. So that's 70 times P, so that's 0.5. Has to be greater than or equal to 10. So I'm going to just draw that. It looks a little sloppy, but it's okay. And we'll go back to that. And then also, right, 70, so this is the N times P we just did. Now we need to do N times 1 minus P. So that's 70 times 1 minus P. That has to also be greater than or equal to 10. Check, check, and check. We met our conditions. Now here's the part that we do. We put our method. What are we going to do now? Because we've met those conditions. And now what we're going to do is we are going to use a one sample z-test for P. And that's all you're doing today, guys. You're reading the problems, you're going through the state, you're going through the plan. Hopefully it's not too bad. You have only 3 new pieces, that random, independent, normal, and then seeing what the method is. If you have any questions, make sure you guys reach out to your teachers. You guys have a wonderful day.